Okay. Okay, Pata. Shall we start today's lesson? Okay. In our last lesson, we have discussed about the second application of dimensional analysis. Second application of dimensional analysis. What is the second application, Putta? Can anyone tell me? What is the second application? Hmm? Hmm? Determining the dimension of unknown physical quantity in an equation. Suppose we are given an equation and there are several unknown physical quantities and we have to determine the dimension of them. In such cases, how we determine those kind of dimension? That is our application. So we were discussing about that thing. In that case, we have to consider some factors, some factors or some mathematical methods to be adopted during this analysis. The first factor to be considered is, we have discussed that one. If there is an equation, if there is an equation A plus B plus equals C plus D, this kind of equation, if there is an equation, or each and every term in that equation should have same dimension, Putta, because all of those physical quantities should have same dimension. That means the dimension of A equal dimension of B and equal dimension of C equal dimension of D. Okay, each and every term should have same dimension. That is the first factor to be considered during this analysis. And the last class, I have clearly mentioned what is a term. What is a term of an equation? Because you should understand that thing. Okay, term. If there is an addition or subtraction, the physical quantities that are combined through an addition or subtraction is called as a term. So this is a term. So this is a term. Term 1, term 2. This is term 2, 3. This is term 4. If there are quantities which are combined with addition or subtraction, those quantities are called as terms. Okay. As example, suppose there is AB over C minus DC over R is equal A to the power X over 2Y minus Z plus Z. Suppose we are given this kind of equation. Suppose we are given this kind of equation, Putta. So what are the quantities that are combined with minus or plus signs? What are the quantities, Putta? In here there is a minus sign. So these two quantities are combined through this minus sign. So this is a term. This is a term 2. So we can consider this as term 1. This as term 2. Then there's another addition here. Through this addition, this quantity and this quantity are combined. So this one is a term and this one also a term. This one also a term. So we can consider this as term 3 and term 4. I think in yours you should do this one. Okay. Anyway, those are the terms of an equation. So what is my first factor? What is my first factor to be considered during this analysis? Each and every term in an equation should have same dimension. That is the first factor to be considered. Okay. So second factor. What was the second factor, Putta? What is the second factor? Tell me. First factor is this one. The second factor to be considered. Give me answer. Give me the answer. What is the second factor? What is the second factor? What is the second factor? කෝ කතා නැද්ද කට්ටිය? Yes, very good. Very good. So if there is an addition or subtraction, in an equation, these two physical quantities which are combined with addition or subtraction should have same dimension. According to that factor, A and D should have same dimension. Okay. Suppose this one, a to the power x plus y equal b to the power is it x over p plus q. Suppose this one. According to that factor, there is an addition. No, there is addition. So if there's an addition, these two physical quantities that are combined through addition should have same physical quantity, because we cannot add different physical quantities. The best example is you cannot add time to a kilogram. No, you cannot add. No, you cannot add time to a liter. You cannot add. So we cannot add or subtract two different physical quantities. So these two physical quantities should be same. Therefore, the dimension of x should be equal to the dimension of y. Likewise, dimension of this term z x over p should be equal to the dimension of q. So according to this second factor, dimension of x should be equal dimension of y. Then dimension of x over p is equal dimension of q. Okay. Yeah. Powers are numbers. These are numbers. Okay. That doesn't matter. So if it is a power, this one should be a number, then this one should be equal to 1. Okay. The dimension should be equal to 1. Okay. That is our third term. That is our third factor. Okay. That is our third factor. But my second factor is if there is a addition or subtraction. The physical quantities combined through addition or subtraction should have same dimension. That is my second factor. My third factor, I think we have discussed that one also. Third factor is if there is a power. A power should be a number, Putta. Power should be a number. Not the base. Base can be any physical quantity, but the power but the power should be a number. It should be a number. So if there's a power, the dimension of power is equal to 1, or it has no dimension. It doesn't have a dimension. So if there's a power, that means the power doesn't have a dimension, as it is a number. So if any physical quantity in a power, then they do not have a dimension. Suppose we are given a to the power x equal b to the power py plus q, then this is a power, then the dimension of x should be equal 1. Dimension of x should be equal 1 because x should not have a dimension. So dimension of x should be equal 1. That means no dimension. Then this one, this whole thing is a power. This entire thing is a power. Not p, not y, not q, but the power is py plus q is the power. The entire thing is a power. So the entire thing should not have a dimension. That means dimension of p plus q should be equal to 1. Should be equal to 1 means actually no dimension. Okay. If you are writing answer for essay question, don't stop from this one. Okay, don't stop from this one. Then you have to write this physical quantity does not have a dimension, no dimension. Okay, don't put one only. Okay, so in this case, p plus q equal to 1. Dimension of p plus q is equal to 1. That means no dimension. If this physical quantity does not have a dimension, that means we can consider our second factor here. Because if there's an addition of subtraction, the both quantity have same dimension. Quantities have same dimension. So the total dimension is 1. That means it doesn't have dimension. So individual dimension should not have dimension to no. And q, dimension of q is equal to 1. Okay. The same argument can be used in here. This is a power x to the power, so a to the power x plus y means x plus y. X plus y is a power. So if it is a power, it doesn't have a dimension. So x plus y doesn't have a dimension. That means dimension of x equal dimension of y, and both do not have a dimension. Both physical quantities do not have a dimension. Then this one also, b to the power zx over p minus q. So zx over p minus q is our power. It is a power. So this part, this entire thing does not have a dimension. That means zx over p minus q, it does not have a dimension. Then we can consider our second factor here again. There is a minus sign. So the physical quantities combined with this minus sign should have same dimension, Puta, and the entire thing doesn't have a dimension. So this physical quantity and this physical quantities do not have dimensions. Okay. That is how we determine the dimension of unknown physical quantities in an equation. But there are two another factors to be considered. Okay, up to this level, do you have any question to ask, or do you understand this one? Good. Very good. Okay. Okay, Puti. Okay. Now we can start our today's lesson. That means the fourth factor to be considered, I think this one you already know. That is about logarithm function. Logarithm functions. Logarithm functions. Actually, we have discussed this one in unit lesson also. If there's a logarithm function, normally logarithm functions are defined for numbers only. Numbers only. Okay. So if we have this kind of expression, we can actually, this is a power. If we have this kind of power expression, we can write this power as a logarithm function. So in the logarithm function, this is the base, and this is the function, and this is the power. So we can write this one as log 2 y is equal x. Okay. Normally logarithm functions are defined for numbers only. So base should be a number, the numbers only. So if it is a number, we know this one, the indices or the power, it is also a number, no putta. This one also a number. This one, definitely this one should be a number. If this one is a number, and if this one is a number, then y should be a number 2. Y should be a number 2. So if the base is a number and the power is a number, then definitely y should be a number. Definitely y should be a number. Definitely y should be a number. That means if there is a function or any expression within this logarithm function, not a function, actually, if there is an expression within a logarithm function, this expression should be a number, Buddha. This one should be a number. Okay. So the expression within this logarithm function should not have a dimension. It should not have a dimension. Okay. So according to this argument, y is a number. So y doesn't have a dimension. That means dimension of y is equal to 1. Okay. Do you understand this one? Everyone? Good. Others? Good, good. Okay. Normally, logarithm functions are defined for numbers only. Therefore, the base should be a number. We know about x. X means power. Power is definitely it is a number, no? So the power of a number, definitely should be a number. So y should be a number 2. Y should be a number 2. Sorry. Sorry. Therefore, y doesn't have a dimension. Okay. Write down this one. Fourth factor. Okay. Fourth factor. Fourth factor. Number 4. Under the fourth factor, write down this. Logarithm functions are defined for numbers only. Defined for numbers only. Okay, write down these two. Y equal to the power x. Then we can write it as a logarithm function. So log 2 to y is equal to x. Okay, right under that, if the base is a number, and the power is a number, y should be a number 2. Y should be a number 2. Y should be number 2. Okay, write in another paragraph. Therefore, if there is an expression, within a logarithm function, within a logarithm function, within a logarithm function, that expression should not have a dimension. That expression should not have a dimension. Okay, look at this. Look at the example one. Look at the example one. So in that case, there is an expression within the logarithm function. What is the expression within the logarithm function? AB. AB is the expression within the logarithm function. So that expression does not have a dimension. So the dimension of AB should be equal to 1. Okay, don't say 1. It does not have a dimension. Okay, no dimension. So in here, actually in here, if you are given the dimension of A, if you are given the dimension of A, you can determine the dimension of B, simple B, and capital A and capital B. How to do that? If you are given the dimension of simple A, then definitely you can determine the dimension of simple B and capital A and capital B. How to do that? Can anyone tell me how to do that? There are four terms. Not terms. There are four letters. Okay. Well, four physical quantities. Among those physical quantities, the dimension of simple A is given. The dimension of simple A is given. So how to determine other three? How to determine other three? Can anyone tell me? I just want the argument or logic only. Yeah, you can give the answer. You can unmute and give the answer. Do you understand about the question? No. Sorry. Okay, my question is, this is our equation. In that equation, we are given the dimension of simple A. Actually, there are four physical quantities. No, four physical quantities. One is simple A, other one is simple B, capital A and capital B. Those are the four physical quantities we have. Okay. Among those physical quantities, we are given the dimension of simple A. We are given the dimension of simple A. Suppose it is as simple A. The dimension of simple A is equal A. The dimension of simple A is equal to 6. So if the dimension of simple A is equal to simple A, then tell me how to determine the dimension of rest of 3. You are given this one already. Sorry?
According to the second factor, we can say A plus B have the same dimension.
Capital A plus capital B have same dimension. Yeah. No?
Yes.
Yes. So dimension equal to? The dimension should be equal to?
Triple A.
Not equal A, Puta. Not equal A. Look at this. This is a logarithm function, no? This is a logarithm function. This one is a logarithm function. This one is a logarithm function. So, the addition of two physical quantities is equal to a logarithm function. Logarithm function. You know, a logarithm function is a number. It's a number, no? This one is a number. Logarithm function also a number. Inside that one, that expression also a number. Logarithm function is a number. Definitely, it is a number. Then this one also a number. Okay, this one also a number. Therefore, this one should be equal to a number. Therefore, dimension of A is equal dimension of B. That one should be equal to 1. To 1. Okay, to 1. The other thing is the inside this expression, inside the logarithm function, inside that logarithm function, AB is the expression. AB is the expression. So according to our fourth factor, this expression should not have a dimension, Puta. If it doesn't have a dimension, definitely, I can say the dimension of A multiplied by dimension of B is equal to 1. Look at this. Dimension of A into dimension of B equal 1. And we are given the dimension of A is simple A. If it is simple A, I can substitute this value to this equation. Then dimension of B is equal to 1 over A. 1 over A means, Puta, A to the power minus 1. A to the power minus 1. That is the way of determining the dimension of other physical quantities. Do you understand how I calculate this one? Everywhere. Others? Okay. Puta, this is a logarithm function, no? A plus B is equal to logarithm function. It is a logarithm function. So if it is a logarithm function, it is a number, no? It is a number. So A plus B is equal to a number. A plus B is equal to a number. So definitely, because this one, again, y is equal to 2 to the power x. If y is equal to the power x, I can write this one as a logarithm function. How to write this one as a logarithm function? Log 2 to the power, well, log 2 to y is equal to x. Log 2 to y is equal to x. That means this one is logarithm function is equal to a power. Logarithm function is equal to a power, Puta. The entire logarithm function is equal to a power. Power is a number, no? Power is a number. So the entire logarithm function is equal to a power. That means it doesn't have a dimension. It doesn't have a dimension. Do you understand this logic? Okay. So this one does not have a dimension. Then a plus b is equal to a number. Therefore, a plus b is a number. That means a is a number and b is a number too. A is a number and b is a number too. Therefore, this we can calculate this one as therefore capital A, dimension of capital A, dimension of capital B is equal to 1. Then we can get the, we can consider the next factor. What is that next factor? This one. Within this logarithm function, this is the expression. This is the expression within this logarithm function. So within the logarithm function, there should be a number. Therefore, a into b is a number. A into b is a number. So if it is a number, dimension of a and dimension of b, the product of dimension of a and dimension of b is equal to 1. Now, the dimension of a is given, so it is equal to a. So a into dimension of b is equal to 1. Then we can find the dimension of b, that is equal to a to the power minus 1. Do you understand? Very good. Others? Others? Okay. I think we have to write this example. Okay. I will erase this one. Okay. Okay. After completion, after under the paragraph, write this example. Only the example. Only the example. I will give the question. I will give you the question. Only the example. You have to write only the example. I will give the question. Log base 10 AB is equal A plus B. A plus B. Under the question, write this one. If the dimension of simple A, if the dimension of simple A is equal, if the dimension of simple A is equal A, if the dimension of simple A is equal simple A, find the dimension of other three physical quantities. Find the dimension of other three physical quantities. Then after this one, as a logarithm function is a number. As a logarithm function is a function. It's a number. A plus B equal to number. Therefore, dimension of A plus B is equal to 1. That means how? Yeah, that's a good point. So if it is a logarithm function, this one also a power. No, if it is a logarithm function, if I convert this one to a power, then we can write 10 to the power A plus B is equal to AB. 10 to the power A plus B is equal to AB, then A plus B is the power. If A plus B is a power, that means that is a number. Very good argument. Very good argument. Please let me know once you complete the writing, okay? Please give me a thumb. Good. Others? Okay. Okay, Priti. You can write as a special note. As a special note here. What is that one? Y equal 2 to the power x. Y equal 2 to the power x. We can write it as a log function. Log 2 y is equal x. So this is a power, no? This is a power. If it is a power, this is a number, no? If it is a power, this is a number. Therefore, x is a number. X is a number. Therefore, this log function, log power y is a number. Is a number. Therefore, logarithm functions are numbers, no? Logarithm functions are just numbers. Are numbers. You should write this one. මෙහෙම ලියලා කොටු කරගත්තත් කමක් නැහැ. ඒක ගොඩක් වටින ලොජික් එකක්. Okay. So according to this logic, logarithm function also a number. The expression within the logarithm function also a number. Also a number. Both are numbers. Okay, with it. My second example. My second example is something like this. Log 10 to the power 10, B R over T plus Q is equal P over Q minus R. Okay, that is our equation. In here, sorry, P over T minus R. Okay. If okay, this is our equation. This is our equation. What is the equation? Log base 10. The function is br over t plus q, that is equal to p over t minus r. P over t minus r. Okay. So if the dimension of t is equal to capital T, find the dimension of rest of physical quantity. Find the dimensions of other physical quantity. Physical quantities. This is my second example. Okay, don't write in. You have to write this question. You have to write the question, but you can take a rough sheet and do the calculation and tell me what is the answer. Then you can write in your book. First, you have to try it in a rough sheet. Okay, then tell me the answers. Tell me the answers with the correct arguments. Okay, Tagala correct. Good. I will check. Yes, phone. Buddha, if dimension of t is equal to, don't write t equal to, dimension of t is equal to. Now you can apply dimension of t, Buddha. Your argument is correct. Your arguments are correct. You can apply the dimension of t and get the answers. Others, once you complete the question, you can take a photo and send it to me. Okay. Okay, your R and V are almost same. Okay, this one, you, yeah. What is the answer for B, Buta? B, B. Where's the others? Everyone. Do we are given this one. Okay, we are given this one. Uh, what is the dimension that we are given? Dimension of T is equal to capital T. That is the only dimension that we are given. Okay, we have to find the other dimension with respect to T. Okay, with respect to T, we have to use capital T and get the dimension of other. Okay, we cannot use the dimension of P, Q, and others as P, Q, and R. Okay. We cannot take that one. Your argument is correct, but the thing is, what my question was, if the dimension is dimension of capital T is equal to T, then find the other dimensions using other physical quantities. Physical quantities. You have to find the dimension of other physical quantities using capital T. Ko, Anita Karad. Okay, everyone. Was it me do? Actually, I have write this one. P dot Q means physical quantities. Okay, that is the problem. I think මම කම්මැලි කමන මේ physical quantities කියලා කියන්නේ නැතුව p.q කියලා ලිව්වා. ඒ කියන්නේ මේ ක්‍රමාවක් නෙවෙයි තිබුණේ. හරි? Okay. එතන that should be corrected. P physical quantities as physical quantities පුතා. Everyone, this is the correct question. If the dimension of capital T is equal to T, find the dimension of other physical quantities in this equation. In this equation. Okay. මෙන්න මේක හොඳට මතක තියාගන්න. මේ වගේ questions කරනකොට අපිට එන equation එක සමහරවල්ලාට ගොඩක් ලොකු equation එකක් වෙනවා. හරිද? එතකොට අපි හරි තැනින් අල්ල ගන්න ඕනේ. හරි තැනින් අල්ලගත්තොත් අපිට ගොඩක් දුර යන්නේ නැතුව, ඒ කියන්නේ ලොකු calculations නැතුව ගාන හදන්න පුළුවන්. හැබැයි අපි වැරදි තැනින් අල්ලගත්තොත් එහෙම calculation එක ගොඩක් ලොකු වෙනවා. calculation එක ගොඩක් ලොකු වෙනවා. ඒක කරගන්න එපා. basic logics වලට යන්න. හරිද? මම දැන් කියා දෙන්න. Shall I erase this one? Shall I erase this one? Everyone. Okay. Okay, Buddha. Look at this. We are given this one only. We are given this one only. Okay. And asked to find others. Asked to find others. Then the easiest physical, what are the easiest physical quantity to determine their dimension? What are the easiest one? Without calculation, without doing any calculation, there are some physical quantities that can be determined, that their dimension can be determined. What are the easiest physical quantities in this case that we can determine their dimension? What are the easiest one? අපි අන්නතරින් තමයි අල්ල ගන්න ඕනේ. What are the easiest one? Q and R. Yes, Q and R. Those are the easiest one because Q and R are single physical quantities, no? Those are not combined with others. Those are the single physical quantities, and we can get their dimension from a logic, from a logic only. Without doing any calculation, we can get their dimension. You know this one, this logarithm function. The logarithm function is a number. Then this one should be a number. This one should be a number, no, Putta? If it is a number, then R should be a number. R should be a number. Therefore, the dimension of R is equal to 1, or you should write no dimension. එක කියලා විතරක් ලියලා ඉන්න එපා. No dimension කියලා ලියන්න. No dimension. Because R is a number. That is the reason. You should write the reason too. Then, inside the logarithm function, as we discussed earlier, there should be a number inside a logarithm function. So the expression within the logarithm function should be a number. Putta. According to that argument, Q, dimension of Q is equal to 1, 2, no? Because this is a number. If it is a number, Q is also a number. Q is also a number. This means no dimension. No dimension, don't write 1 only. Don't write 1 only. If you write 1, please write within the brackets no dimension. What is the reason? You should write the reason too, because Q is a number. Q is a number. Those are the two physical quantities that can be determined without any calculation, using a logic only. Everyone, do you understand this one? Everyone, Putta? Do you understand? Very good. Others? Very good. So those are the two dimensions of Q and R. Q and R. Q and R. Okay. Shall I erase this one? Shall I erase? Okay. First write down this. Okay. Shall I erase this one? No? Okay. Then, now I know the dimension of R, dimension of Q. And we are given the dimension of T. We are given the dimension of T as T. Then we can use that one to find the dimension of P. I know the dimension of P over T. P over T should be a number, no, Buddha? It should be a number because this one equal to number, no? So this part, P over T, the entire part should be a number. So P over T, my argument, is a number. Is a number. Therefore, the dimension of P over dimension of T is equal to what? Is equal to what? That means dimension of P equal to dimension of T. Dimension of T. Cross product, using cross product. Therefore, dimension of P is equal to capital T. Capital T. Everyone, do you understand this calculation? Okay, others? Others? Good. Others? Okay. This is my argument, Puta. P over T is a number, no? P over T is a number. Is a number, therefore, P over T doesn't have a dimension. That means the dimension P over dimension T is equal to 1. So, therefore, dimension P should be equal to dimension T. That is my argument. Then we can consider this one. B R over T, the term BR over T, BR over T, that is in the logarithm function. So the entire expression within the logarithm function doesn't have a dimension. That means the each and every term within the logarithm function should not have a dimension. According to that logic, this term should not have a dimension. According to that logic, this term should not have a dimension. So BR over T is a number. Therefore, it doesn't have a dimension. Dimension B into dimension R over dimension T over dimension T should be equal to 1. Should be equal to 1. I know the dimension of R. Dimension of R. I know dimension of R, that is equal to 1. That is equal to 1. Therefore, I can write this one. Dimension of R is equal to 1. Therefore, dimension of B over dimension of T is equal to 1. That means dimension of B is equal to dimension of T. So, that is equal to T. That is equal to T. That is equal to T. Then, all the others should write this one. After writing this one, you can write the third example. Third example. After finished writing of second example, you can write the question number 3 and you can write the question, you can try the question number 3 in a rough sheet and send that to me. Question number 3. Once you try out the question number 3, please send me the answers. Then I can check. Do please look at the answer for Q and R again. Q and R again. Q and R. Was it me? Please look at again Q and R. Q and R again. In this case, we have to consider one more thing. You have to consider one more thing. Please think carefully. Okay? Please think carefully. මේක පොඩ්ඩක් ඇඩ්වාන්ස් මට්ටමේ ගන්න. හරි. Yes, you got the point. You got the point. Your answer is correct, Puta. Okay, everyone. Okay. I will explain. Okay, everyone, look at this. Everyone, look at this. You know this one, logarithm function. This one is a logarithm function. Okay. But in this case, logarithm function is multiplied by another physical quantity. You know a logarithm function. Logarithm function is a number. It is just a number. So number is multiplied by a physical quantity. That doesn't matter, no? Suppose there is a velocity. If there is a velocity, we can multiply that velocity by 5. We can multiply that velocity by 5, no? 5 times the previous velocity. No? 5 times the previous velocity. So we can multiply any physical quantity by a number or by any physical quantity. That doesn't matter. Okay? We can do anything. This is just a number, no? This is just a number. 5 or 10 or 6 or 4 or this is just a number. So this number is multiplied by a physical quantity. Then what is the dimension of the entire left hand side? What is the dimension? Huh? What is the dimension of the physical quantity into a number? So the dimension of left hand side should be equal to the dimension of P. Now it is not a number because number into physical quantity. Number into physical quantity means there is a product. There is a multiplication here. Like this one. If I multiply 5 by 5 ms minus 1, we will have 25 ms minus 1. 25 ms minus 1. That means it is a velocity. It is a velocity. So a velocity is multiplied by a number. A velocity is multiplied by a number. This part doesn't have a dimension, but this one has. So multiplication of number and velocity is resulted a velocity. Understand? Do you get my point, everyone? No? Others? But logarithm function there's p also. But we may that's why we need to find the dimension of b also. We have to determine the dimension of b. So if it is a number, then definitely the dimension of b also equal to the dimension of p, Niputta. Huh? This one also ms minus 1, this one also ms minus 1. Ms minus 1 to ms minus 1 will be cancelled out. Then that will become a number 2. Do you understand that one? Okay. Okay. I will come to this part. I will come to this part. I will come to this part. But now I want to clarify this one. Now I want to clarify this one. Everyone should ask. Everyone listen me. Everyone listen me now. Okay. Don't do anything. Don't do anything. Don't write anything. Everyone listen to me. Here we have P multiplied by a logarithm function. Log B over P plus B. There's a multiplication. There's a multiplication. The first thing you have to know is this one. Because this is a logarithm function. This is a logarithm function. Logarithm function means, Puta, it is just a number. It is just a number. Number means something like 2, 3, 4, not a minus 1, 2, 3, 4, 10, something like this. It is just a number. So this number is multiplied by P. P is a velocity. So velocity multiplied by a number, that result a velocity 2, no? Suppose 5 into P. 5 into P. 5 into P means 5P. 5P. No? So if I multiply a physical quantity by a number, then I will have the same physical quantity. No, the physical quantity doesn't change. Right? So according to that argument, the left hand side is equal to the multiplication of P and a number. Therefore, the dimension of left hand side is equal to the dimension of velocity. Everyone, do you understand my logic? Do you understand my logic? Others, do you understand my logic? Uta?
Sir, can you please explain again if you don't mind?
Okay. Very good. If you don't understand, please let me know. I will explain it again. Okay? Okay. Okay, Buddha. Suppose this one. Suppose this one. Suppose there is a velocity. There is a velocity 5 ms minus 1. Okay. You have to multiply that velocity by 5. You have to multiply that velocity by 5. If you multiply this velocity by 5, what will happen? What will be the result? What will be the result, Puta? It is 25 ms minus 1, no? 25 ms minus 1. I will give you example. Okay? Okay. Sorry. Okay, Buddha. I will give you an example. What is that? Suppose you are going to a shop and ask a 5 kg sugar. 5 kg sugar. Okay. 1 kg sugar packet. 1 kg sugar packet. Okay. You are going to the shop and asked to buy a 1 kg sugar packet. Okay. Now, what is your objective? Buying 1 kg sugar packet. And your mom called you and asked to bring 5 more sugar packets. 5 more sugar packets. 5 more sugar packets. Then definitely your quantity will be multiplied by 5. Your quantity will be multiplied by 5 times. No, initially you plan to bring 1 kg. Now it's become 5 kg. No, it's become 5 kg. So how to find that part? You have to multiply 5 by 1 kg. If you multiply 5 by 1 kg, you will have 5 kg sugar, no? Initially, you plan to bring 1 kg sugar packet. Now the weight is 1 kg, but suddenly your mom call and may tell you, give another 4. That's mean 5 kg sugar packets. Then what will be your weight now? It will be 5 kg, no? 5 kg. It will be 5 kg. Then how to find the final weight? You have to multiply 1 kg sugar packet by 5. Then your final weight is 5 kg. My final weight is 5 kg. Likewise, if I multiply any physical quantity by a number, if I multiply any physical quantity by a number, this is just a number, we will have the same physical quantity. Okay. I can prove this one using dimensional analysis. I can prove this one using dimensional analysis. Suppose there's a number. And multiply by a. Suppose there's a number multiplied by a physical quantity. PQ. Physical quantity. PQ means physical quantity. It means physical quantity. So if I multiply this one by, okay, suppose the physical quantity is A, and then suppose 5 into A is equal to B. What I have done is, this physical quantity has been multiplied by a number, and suppose my answer is equal to B. Now my objective is finding the dimension of B. So how to find the dimension of B? We have to apply dimension of other these two, no? Dimension of B should be applied, so should be equal to dimension of A and dimension of 5. Dimension of B is equal to dimension of 5 and dimension of B. So what is the dimension of 5? What is the dimension of 5? It is a number, no? Nebuta. It is a number. So dimension of 5 is equal to 1 and dimension of B. So dimension of B is equal dimension of B. Dimension of B is equal dimension of B. That means if any physical quantity is multiplied by a number, then we will have the same physical quantity, no? Same physical quantity. That doesn't change. Do you understand my argument? That argument?
Yes.
So if any physical quantity is multiplied by a number, we will have the same physical quantity. That doesn't change. That won't be changed. Okay. That is my argument. Now we can use that argument in this question, Putta. In this question. How can we apply that one? You know this part, this logarithm part. This logarithm function is a number. This is just a number. Even it is a very long expression, it is just a number. It is just a number. So P is multiplied by a number. P is a physical quantity and it is multiplied by a number. So something like this. P is multiplied by a number. So the left hand side, the dimension of left hand side should be equal to the dimension of P. Dimension of P. Do you get my that argument? Very good. Others? Others? Okay. 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 So this is just a number. Number is multiplied by a physical quantity. Then we should have the same physical quantity. So the left hand side of this equation is represented a velocity because it is equal to the dimension of P. Dimension of P. Okay. Okay. මේකත් අපි ලියා ගමු. Suppose we have to multiply a physical quantity by a number. This is a knot, okay? This is a knot. Okay. First, you should write this knot. This knot. Suppose we have to multiply a physical quantity by a number. 5 into A is equal to B. Then dimension of A, dimension of B is equal dimension of B into dimension of A. Dimension of 5 is equal to 1. Right up this level, right up to this level, right up to this level. Therefore, if we multiply a physical quantity, PQ means physical quantity, by a number, we will have the same physical quantity. Okay, write this one as a knot, as a knot. Suppose we have to multiply a physical quantity by a number. Then after that, you can write up to this. Then after that, you can write this argument. Therefore, if we multiply a physical quantity by a number, we will have the same physical quantity. Very good. Others? Once you write this one, please let me know or give me a thumb. Good, good, good. Okay. Shall I erase this one, Puta? Okay. Okay, now we can go to the question. Then another question we can write P into, sorry, log 10 to the power B over P plus B. I know this one is a number. This one is a number. This one is a number. Therefore, the dimension of P into log B over P plus B should be equal to the dimension of P. Should be equal to the dimension of P. Therefore, the dimension of LHS is equal to the dimension of P. According to this argument, LHS is velocity, is a velocity, then RHS should be a velocity. So the R plus Q should have same dimension, which is equal to the dimension of velocity. So therefore, LHS, dimension of LHS should be equal dimension of RHS. That means R plus Q. R plus Q should have dimension of P. Dimension of P. Therefore, dimension of R is equal, dimension of Q is equal LT minus 1. LT minus 1. LT minus 1. Both should have dimension of velocity. Okay. Okay, everyone. Okay, everyone. Please look at the board. Please look at the board. Everyone, stop writing and please look at the board. I will give you time. Okay. Then, according to this argument, LHS have dimension of P. Therefore, RHS should have dimension of P. That is velocity. So in RHS, there's addition P plus Q. So, sorry, R plus Q. So R plus Q have dimension of P. That means dimension of R is equal dimension of Q. That is equal LT minus 1. Do you get my point, everyone? Please give me a response. Good, 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 good. Okay. Then my next argument. Next argument is any expression within a logarithm function should not have a dimension. Any expression within a logarithm function doesn't have a dimension. Therefore, B over P plus B, dimension of B or plus C equal 1 because any expression within a log function doesn't have a dimension. Doesn't have a dimension. Therefore, any expression within the log function doesn't have a dimension. Therefore, I can say dimension of B is equal to 1 because this one should be equal to 1. That means no dimension. Then B over P should be a number too. B of P should be a number. Therefore, dimension of B is equal dimension of P. You have to cross product this one, dimension of P. So that is equal LT minus 1. LT minus 1. Do you understand this one? Everyone? Good. Okay. Now you can write this. Once you write this, please let me know. R and Q cannot be numbers, Puta, because there's a R and Q, R plus Q is equal to this side, no? R plus Q is equal to this side. This side represents the velocity. For definitely R and Q should be a velocity, Sutta. Okay. Okay, everyone. I can understand why did you ask this question. Please correct me if I'm wrong. You try to convert this logarithm function into a power. Did you try? Hmm? Did you try? Did you try to find? Did you try to find convert this logarithm function into a power? Ah, okay. I thought if you want to do that, you should subject that one first, Puta. If you want to do that, first you should subject logarithm function. If you want to subject logarithm function, you should divide both side by p. Both side by p first. Therefore, log 10 to the power, this one is equal r plus q over p. R plus p q over p. Okay. Now you have subject logarithm function, then you can do that. Look at this. In this fraction, the numerator is also a velocity and denominator also a velocity. Velocity to velocity, ms1 minus 1 to ms minus 1 will be cancelled out. The fraction will be a number only. Fraction will be a number only. Then you can write 10 to the power p plus q, so r plus q over p is equal to this part. Equal to this part. Now, this one is a number. This one is a number. This entire thing, r plus q over p is a number. Do you understand this one? Adu? Okay. Good. I think you should try something different things. Okay, then you can understand everything very clearly without any doubts. Okay, very good, that one. Okay, if you want to convert this thing into a power, into indices, then you should subject the logarithm function. Okay. Shall I erase this? Okay, welcome. Shall I erase this one, everyone? Okay. Okay. The final factor, the final things that should be considered in our analysis is trigonometric functions. Trig functions. You know, within a trig function, suppose sine theta, cos theta, within a trig function or trigonometric function, you know there should be a angle. There should be a angle. So what is the dimension of an angle? What is the dimension? An angle dimension in trigonometric function, definitely there should be angle. There should be angle. This one is angle. So what is the definition? So no dimension. What is the dimension of an angle? Abuta? Call am I? Please give me an answer. What is the dimension of an angle? No dimension. Very good. It does not have a dimension because according to the definition of angle, S equal R theta, we should use this definition. So according to the definition, theta is equal S over R, S over R, S over R. S is the arc length, R is the radius. So both are lengths, both are lengths. So the dimension of theta is equal L over L. L over L means 1. L over L means 1. Therefore, an angle does not have a dimension. Therefore, actually, we can use the same argument like in trigonometry, like in logarithm functions. So any expression within a trigonometric function does not have a dimension. But there is a difference, Puta. There is a difference. In a logarithm function, there was a number. But in a trigonometric function, there is an angle. So two different physical quantities are there. But thing is, both do not have dimension. Okay. Sometimes in MCQs, you are asked to determine the physical quantity represented by some part. Okay, something like this, such as suppose you are given this kind of expression: Vx over t plus q is equal to something like that, and you are asked to find the physical quantity that is represented by q. So what is the physical quantity represented by q? Give me an answer. What is the physical quantity represented by q? Physical quantity. Now we are not asked to find dimension. We are asked to find or asked to determine the physical quantity that is represented by q. Everyone. Yes. Look at this, Puta. In trig functions, within that function, there should be an angle. Therefore, this entire expression should be angle. If the entire expression is angle, if the entire expression is an angle, then Q, definitely Q should be an angle. It is differ from logarithm function, okay? In a logarithm function, within the function, it should be a number. So there is no physical quantity in logarithm functions. But trigonometric function, there is a physical quantity that is angle. There is a physical quantity that is angle. But the thing is that physical quantity that does not have a dimension. Okay, that does not have a dimension. Okay. Do you understand, everyone? Please give me a thumb if you understand, or if you need any clarification, please let me know again. Very good. Okay, so write the final factor for fifth one. Okay, write this one. If there is a trigonometric function, trigonometric function the expression within the function, the expression within the function, the expression within the function should be an angle, should be an angle. An angle does not have a dimension, does not have a dimension. An angle does not have a dimension. You can write this one after that. After that, write this one. After that, write this one. S equal r theta. Therefore, theta is equal S over r. The dimension of theta is equal 1. Okay, right under this, right under this. Therefore, if there is an expression, if there is an expression, within a trigonometric function, that expression won't have a, that expression that expression that expression will not have a dimension. Okay. They write in a new paragraph, but the physical quantity is an angle. මේක ලියලා කොටු කරගත්තත් කමක් නැහැ. මේක very important factor because these kind of questions can be asked. Okay. Example. Sin A plus B. Sin A plus B. Look at this one. Sin A plus B. According to our previous argument, A plus B should be a angle, so it doesn't have a dimension. Therefore, A plus B is an angle. Therefore, the dimension of A plus B is equal to 1. Therefore, dimension of A is equal, dimension of B is equal 1. Okay, up to now. Okay. Once you write this one, please let me know. First, once you write this one, please let me know. Okay, putra. Okay, මෙතනින් අපි අපේ first unit එකේ dimension part එක unit and dimension part එක ඉවරයි. So we have finished unit and dimension part of the first unit. Now we have a balance. What is that? The practical session. So we have to study about measurement instrument. That is a practical session. So actually, if I arrange a physical class for practical session, actually most of the situation in Gampaha and Colombo. So if I arrange a physical class in Gampaha and Colombo, do you actually can you come to this class for the practical session only? Okay. Others? Okay. Good. So I will arrange a practical session as a physical class in Colombo and Gampaha. I will let you know what is the place, what are the places. Until then, we will continue with second unit, that is mechanics, most important unit in our syllabus. The most important unit in our syllabus. Okay. We will start, but before starting mechanics, we had to do a lot of things in unit of dimension unit, because first thing, we just complete the syllabus. There's another one part, that is classification of physical quantities. I will do that after doing this examples. So after that, we will finish this lesson. And then we are going to do most of questions, each and every questions in our tute. Okay. Then you will have exams. You will have 2 or 3 exams after doing that. Okay. Then I will prepare a paper and let you know how to do this exam. Okay. Because you actually you have to study this very well. Then after that, after completing the tute, okay, you will have 2 or 3 exams. Okay. After that, we will start mechanics. Okay. So up to now, do you have any questions, Buddha? Do you have any question? So if you understood, please let me know. Good, very good. Others, good. Okay. Shall we go to do some examples? Okay. This one. I think we have done few questions here, no? Please let me know up to what which question, up to question 5, no? Up to question 5 we have done, no? Okay. Shall we start from question 6 then? 6 to 10. No, 6 to 30. 6 to 30. We have done another part with equation generation. After that, we can complete this lesson. Okay, that's another part. Once you finish, please send me the answers, okay? Up to question 13. You are given this truth, Pata. The meaning of these words, F, G, M, those are mentioned in the above. If you couldn't find that one, please let me know. I will give you the instructions. Okay. If anyone cannot find the actual meaning of these terms, please let me know. Question number 6. Please look at your answers. Please look at your answers. AZ, dimension of AZ should be equal to dimension of V squared. Okay, V square, not V. There's a small mathematical error. Yes, second one is correct. Yeah, seventh one is okay. Ninth one is also correct. Yeah, in this case, may 10th one do 10th one, may you are given the dimension of u. U is a velocity. U is a velocity. So you can substitute the dimension of velocity here. Okay. Then you substitute the value. Okay. 11th one. Okay. Yeah. Good. And 11th one also, simple M is a mass. Simple M is a mass. You can substitute the dimension value of mass by to your answer. Okay. Very good. Very good. Others? If you cannot find the meaning of those physical quantities, please let me know. Okay. Yes, yes, yes. V squared. In this case, Muta, that's V squared, no? V squared is equal to U squared plus 2AS. V squared means V into V. V into V means velocity into velocity. Velocity into velocity. Okay. Velocity into velocity means there are two velocities. Both terms, actually, both physical quantities have dimensions. So we have to consider this power. Okay. Okay. Shall we discuss? Okay. Look at this, everyone. Everyone. Okay. In this case, we are asked to find the dimension of Z. In here, V is a velocity, U is a velocity, A is a acceleration. A is an acceleration. Okay. Those are given in the tute. If you want to know this meanings, those are in the previous questions. Okay. That's why I do not mention that here. Okay. So now we have to find this one. Find this one. We have to find this one. Then we can use our factor. Use our first factor, that is, if there's an equation, each and every term should be have same dimension. Should have same dimension. So, and other thing is, if there is an addition, if there is an addition in between two physical quantities, then both physical quantities should have same dimension. Should have same dimension. Then this one, A is a dimension of A is a should be equal to dimension of V squared or U squared. Okay. Then that means dimension of A into dimension of Z is equal to dimension of V squared. V means it is a it is a velocity, so we have to take the square of dimension of velocity. Then L squared t to the power minus 2. Then A means acceleration. So here we have acceleration LT minus 2. LT minus 2, Puta. LT minus 2. And here, sorry, into Z dimension. Then here L squared t minus 1. L squared t minus 2. Sorry, t minus 2. T minus 2. Okay. Do you understand up to this? Then L squared to L squared will be cancelled out. Sorry, T squared to T squared will be cancelled out. Then there is two L's and here one L will be cancelled out. So the dimension of Z is equal to L. Equal to L. Everyone, do you understand this one? This calculation? Okay, very good. Then the second one, sorry, seventh one. Here we have S equal U plus Z over T. Then definitely we can say both of those physical quantities have same dimension because these are connected with plus sign. So dimension of U is equal dimension of Z. Dimension of Z. In this case, you have to write the argument, Puta. You have to write the argument. Okay. Within the brackets, you have to write the argument. What is the argument? Addition or subtraction can be done among same physical quantities. Okay. That is the argument. In here, we can use the same argument, or we can use the other factor, that is, if there's a function, each and every term should have same dimension. Okay. I think it is better to write the argument until you familiarize with that one. Okay, until you familiarize with that one, you have to write the argument. Okay, so as a habit, you have to write the reason for each and every step. Then definitely it is very easy to understand the unit. Okay, so write under this one the argument. What is the argument? If there is an addition, the dimension of two physical quantities should be same. Then I can write the dimension of Z is equal, dimension of Z is equal, dimension of U is a velocity, so it is LT minus 1. It is LT minus 1. Okay, do you understand this one? Then this one, E equal mgy plus half mz squared. Then we can take our first factor. What is that? If there is an addition, if there's an equation, then each and every physical quantity should have same dimension. So not physical quantity, each and every term have same dimension. So okay, Buddha, there's a power failure here. Can you hear me? Can you hear me? And can you see the board? Okay. Possibly, can you explain your question? Seventh question, yes. That says, in this case, we don't want to subject U or something, okay? Because if there is addition, definitely these two physical quantities should have same dimension. That is the thing. That thing we can use. Okay. No, Buddha. No, Buddha. No. There's a T, no? There's a T. There's a T. So if I expand this expression, look at this. If I expand this expression, then we will have this kind of expression is equal ut over 2 plus zt over 2. That is our expanded expression. Then this one is equal to this one and this one. So the dimension of S should be equal to dimension of ut and dimension of zt. Okay. Okay. Not to the SI team, because there is another multiplication here. In this multiplication, T is a physical quantity too. T is not a number. T is a physical quantity. So if it is a physical quantity, then you should expand the equation first. You should expand the equation first and take the dimensions. Okay. But the thing is, in this case, we do not want to expand the equation because we can use our second factor. No? What is that? If there is an addition, if there is an addition, then both physical quantities should have same dimension. We can use that one. Okay. If you don't want to use that one, then you can expand the equation. Then you can use the first factor. Do you understand? Do you understand, Buddha? Is it not? Are you clear with that? Okay. Okay. Then the next one. Next one is half me squared. This equation. In this equation, you have half me squared. Definitely, there is a power. There is a power here. There is a power here. If it is a power, we said, if it is a power, then definitely that power should be a number. Ask with me. Do you understand this, Buddha?
Yes, sir.
Okay, very good.
Yes, sir. Understood.
Okay, very good, Buddha. Because there is a another physical quantity here, Buddha. Another physical quantity here as a multiplication. So if you want to equalize each and every term, you have to expand. You have to expand and you have to find what are the terms inside this equation. You have to find them. Okay. Until you expand this one, you cannot find what are the terms here. Okay. Okay, in this case, definitely this is a power. This is a power. So y is a power. Therefore, the dimension of y is equal to 1. Dimension of y is equal to 1. That's mean no dimension. That should be right. Okay. No dimension. Okay. No dimension. Because in your first term exam or term, especially term test exams, you may have to calculate or you may have to determine some dimensions of this kind of expressions. So once you determine the dimension of a physical quantity as 1, do not keep it as 1. Within the bracket, write no dimension. Okay, because this 1 is used to calculate. Actually, normally we are using 1 for calculation purposes. Okay, in the equation, if it is not have, if any physical quantity do not have a dimension, we cannot write it where I write this word. No. So during our calculation, we can use 1 as a dimension of dimensionless physical quantity. Okay, dimension of dimensionless physical quantity. Okay, when we are doing calculation, we can assign 1. We can assign 1 for the dimension of dimensionless physical quantity. But if you are when you are calculation, when you're doing calculation and you got the answer, if you got the answer something like this, actually you should write this word. What is the word? Dimension of y. It doesn't have dimension of no dimension. Okay. මෙතන විතර නවත්තන්න එපා. හරි. හොඳයි. Then the eighth one. This one. In this case, we can equalize each and every term. in this case we can equate each term, because now there are no any things to expand. No any things to expand. No, Buddha. In this case, now we don't have anything, any brackets to expand. No. Now all the terms are exports. Now we can equalize each and every term. Okay, each and every term. So the dimension E should be equal to dimension mgy, and that should be equal dimension mz square. mz square. Okay. What is my argument? You should write the argument. What's the argument? In equation, each term should have same dimension. Same dimension. Write it as a very short form. In equation, each term should have same dimension. That is my logic. That is my argument. Okay. Then mgy should have the dimension of energy. Mgy should have the dimension of energy. What is the dimension of energy? It is equal to ml squared t minus 2. Then you can substitute the dimension of mass and gravitational acceleration to find the dimension of y. M is mass, g means acceleration, and we have to find the dimension of y. Dimension of y. Then substitute this one. Once I substitute the dimension of these two, I will have ml squared t minus 2 is equal m into the dimension of gravitational acceleration. Gravitational acceleration is an acceleration. So dimension of g is equal to the dimension of acceleration mlt minus 2 and dimension of y. Dimension of y. Now you should simplify this one. Here there is a L, L2, 1L will be cancelled out, M2, 1M will be cancelled out. T minus 2 to T minus 2 will be cancelled out. Then dimension of y is equal to L. Here L. Dimension of y is equal to L. Dimension of y is equal to L. Then this one, mz square. Then dimension of E is equal to this one. Dimension of M into dimension of Z squared. Okay, Z squared. Then you can substitute dimensions of E and M here and find the dimension of Z. Find the dimension of Z. So what is energy? So dimension of energy is ml squared t minus 2. Here we have m. Then here we have Z squared. Dimension of Z is squared. Then here m to m will be cancelled out. Then we will have this one. What is that? L2 minus 2 equal Z to the power 2. Now you have to take the square root of both sides. Square root of both sides. Then the Z dimension of Z is equal. You have to divide by 2. That means LT minus 1. LT minus 1. Everyone, did you understand about my calculation? Everyone? Do you get my calculation, Puta? Okay. Okay. The 10th and 11th question. 10th and 11th. Okay. Shall I erase this one? Shall I erase this one? Okay. Everybody, look at this. In this case, E is equal half mv u is it. mv into u is it. U is it. Then my argument should be, if there is a power, then the dimension of power should not have a dimension. That means dimension of power should be equal to 1. So this is a number, this part is a number, this part means u is a product. The u is a product should be a number because it is a power. Then the u is a product is a number. Therefore, the dimension is equal to 1. Dimension is equal to 1. Dimension is equal to 1. So the product of dimension u into dimension z is equal to 1. That means dimension of z is equal to 1 over dimension of u. 1 over dimension of u. You have to bring this one to here. Okay, cross product. U means u is a velocity. U is a velocity. So I can substitute that value into this equation. So dimension of z is equal to 1 over dimension of velocity. Dimension of velocity, LT minus 1. LT minus 1. So this is a reciprocal function. So we have to bring them to the numerator. Then I will have the dimension here L plus 1. Then if I bring that to the numerator, it will be minus 1. Here that's minus 1. If I bring it to the numerator, it will be plus 1. T plus 1. So it is L minus 1 T. L minus 1 T. Okay. Do you get my point here? Question number 10. Do you understand? Ninth question. This one? No, Muta. No. We cannot write that one. We cannot write that one. How did you get that answer? Here LT minus 2, no? LT minus 2. If I take the square root of them, that means you have to multiply this one by half sign. No, half, fraction half. If I multiply the power by fraction half, it will become 1. If I multiply this power by half, it will become TL. If I multiply this power by half, it will become minus 1. Okay. If you want to take a square root, definitely this one should be 1. No, this one should be 1. This power should be 1. No, think like this. Because in your questions there may not be square root, maybe power 4 something. Okay, think like this. If there is a power, and you want to find Z, listen very carefully, everyone. If there is a power, and you want to find Z, then this power should be 1. No? This power should be 1, Puta. No? If you want to find Z, we have to bring this power to 1. No, we have to convert this power to 1. If we want to convert this power to 1, what should I do? You had here now here is 2. If you want to 1, if you want 1, you should divide this 2 by 2. You should divide this 2 by 2. No? If you divide this 2 by 2, you will find Z. Then do the same thing to this. If you divide this 2 by 2, you will find 1. If you divide minus 2 by 2, you will find minus 1. Okay. But if there is an addition or something, you cannot do that. Okay. If there is a multiplication or division, you can do. Okay. I'm not going to explain that thing. Okay. Do you understand up to now? Very good. Then the next question, 11th one. 11th one is v squared equal u mx plus z. Sorry, my plus z. My plus z plus 2s. So y and z. In this case, u is u to the power my plus z. U to the power my plus z. My plus z mean it is a power. So it doesn't have a dimension. So my plus z means it is a power. Power means number. It is a number. Therefore, the dimension of my plus z is equal to 1. Sorry, Buta. So dimension of this expression is equal to 1. That means dimension of this one and dimension of this one should be equal to 1, 2, because this is a number. So this part should also be a number. So my equal z equal 1. Z equal 1. From that, we can determine directly the dimension of z equal 1. Sorry. Dimension of my should be 1. Should be 1, 2. Therefore, dimension of m into dimension of y is equal 1. Dimension of m means that is a mass, Puta. So dimension of m is equal m into dimension of y equal 1. So dimension of y is equal, Puta, m to the power minus 1. 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 Okay. Do you understand this one? Do you understand this one? Everyone? Good. Others? Okay. Okay, Buta. Okay. Now, you have to do a homework. No, Buta. We can simplify up to this level. We have to simplify, Buta. Don't keep 1 over m. Don't keep 1 over m. Okay. We have to simplify means you have to take all the m, l, and t terms to the numerator. Okay. Don't put in denominator. Okay. Okay. Okay, Buddha. Today's lesson. Now we are going to finish today's lesson. Up to now, do you have any question? Do you have any question? Now it is time to ask. Do you have any question? Or do you clear with this lesson? Are you clear? Yes. Very good. Very good. Others? Very good. Okay. Okay, Buddha. Then now you have to do some homework. What are those? I think last time I gave you some homework, but still I couldn't find your answers. This one. This one. Now you can finish this additional tute. Okay, this additional, all the questions in this tute. All the questions in this tute. I think we have done up to 25 here. Then you will have to do another 5 questions. And here I think we have done up to 5. Up to 5 here. Now we have done up to 11 here. So balance works you should do. Balance works you should do. And You can upload this tube to my tube substitution group too. Okay, පුතා. ඒකත් දාන්න. එතකොට මට බලන්න ලේසි. Okay. මොකද මට ඕගොල්ලන්ගේ පොත් ටික බලන්න ඕනි. ඒක නිසා ඔයගොල්ලෝ ප්‍රශ්න කරපු විදිය බලන්න ඕනි. සමහර ළමයි ඒ කියන්නේ මේ ප්‍රශ්න කරනකොට මේ අපිට තේරෙනවා මෙයා මේක තේරුම් අරන් දින්නේ නැද්ද ඉන්නේ කියලා තේරෙනවා. ඒක නිසා මට ඒක තේරුම් ගන්න ඕනි. ඒක නිසා ඒක මට පර්සනලි හරි කමන්න පර්සනලි ඕන නම් කෙලින්ම දාන්න මේ tube substitution group එකට. Okay. So you should send your answers to tube submission group. Okay. Please complete all the questions in this tube and upload your answer to tube submission group. Then I will check and let you know if there is any mistake or not. Okay. Okay, Buddha. So now we are going to finish this lesson. So have a nice day and I won. Okay, you're welcome, Buddha.